this video I'm going to take a look at the bushing and possibly the wheel. Maybe I'll do it in two. But the bushing is a little different than the shaft, and one of the reasons it's different is because it's got a hole in it. This is going to be a revolved feature. You could revolve it as a solid and then put a hole in it after the fact. That might be a good way to do that because then the hole size can be controlled directly by actually having it as a hole. The other possibility, though, is to draw it so that it's up off of the axis, so that as you turn the part or revolve the part, the hole automatically gets placed. The other thing about this is it's not symmetrical end to end. I'm talking about the bushing right here. It's not symmetrical end to end, so there's no point in embedding the origin somewhere in the middle of the part. It makes more sense to put the origin either at the center of that face, the center of the back face, or the center of the end face. In this particular case, I like the idea of putting it right there. I'm going to have it centered on that face right there. Whatever you decide on that, by the way, there's no right answer necessarily, as long as you have a justification for it. Okay, I'm going to go back to SolidWorks. I'm going to do my sketch. I'm going to start with the center line. We'll go to the front plane. Could be on the top plane. It would do the same thing. I'll draw my center line so it lines up with the origin. Draw it through the origin so that it turns black. Now I'm going to look right at it in the front. I'll start my line. In this particular case, I'm going to start the line over here, go up, go across, come down, come out, come down to about here, and then come across to about here. Now, I didn't really mean to start this right on the center line, so I'm going to go and trim that little piece out like right here. To trim that little piece out, use the power trim. So now this is floating above the center line because now I can go ahead and do a revolve and have it add that hole automatically when I do it. Smart dimension, indicate by going down below what the overall dimension has to be of that part. If I go back and look, that's 34. Didn't come very close to that when I drew it, but I think it's going to be okay. It's going to be okay, but not great. Now, one of the things that just happened, we'll just go back out of the dimension mode, is that when I did this, I didn't sketch it close enough to the 34 to avoid having a kind of major change. So now I'm going to come back and move that up. Come back and move this down so it's a little closer to what I want. Go back and take a look at the sizes. 22 millimeters for the diameter of the inside piece, and then 12 and 19. So smart dimension from here to here. Go on the outside. 22. From here to here. Do the same thing. That diameter should be 16. Now there's your bushing profile, almost completed. Yes, it is 16. I just wanted to check that out. So now we have the overall length. Well, in order to place this on the, to make sure that it's right on the origin, I'm going to have to do something to constrain its location. But first, let's do the overall length. The overall length on this, 19. And then the distance from here to here, going to be 12. Bring this back out again. Okay, now it is fully defined, and the reason it's fully defined is because that line right there is coincident with the origin. We picked that coincident relation. You notice that it changes color down here and changes color up here. So we actually did line it up on that origin. That's why it's fully defined. Now we get back over to the features, do a revolve base. It automatically revolves it around the only axis it has, which is that center line. There's your bushing. Again, you could have done that as a solid and put a hole in it, but this is a nice quick way to get that geometry.